Recording this. All right, we've started. Okay, we are group MIE 36. My name is Nick Cassell. I'm joined by Andre Jimenez, Jeremy Ovalle, Matt Rothenbaum, and Praveen Gamiri. Uh,
Yep. Our task for this project was to create an end effector that acts like a hand for the robot in the robotics lab. The end effector needed to be capable of securing an object, holding on to that object, and letting go of the object at a designated time. The object being picked up was up to us as a team. We came up with two solid designs for this.
Some of our designs involved soft grippers, mechanical grippers, and vacuum grippers. Mechanical grippers would essentially be involving physically gripping the object with like pincers or some type of mechanical hand. The pneumatic grippers would involve air suction, pneumatic pumps to grip the object and then pick it up. And vacuum grippers would involve essentially inflatable, deflatable balloon that would wrap around the object to pick it up or and drop it as such.
Yeah, the budget for this project given by university was around $500. We we did well below that budget, and the parts we bought were wrist kits, some suction cup, battery pack. Arduino was given by Professor Brown, and motors for the vacuum. And for the parts, we order different parts and compare how they work, and we decided on the best one. And planning of the project, in the beginning, we created a Gantt chart, outlined every date that we should complete the task by, and we wanted our prototype a week or 2 weeks before the expo, and we were able to do that.
yeah, okay, so our prototype design consisted of a few different systems. Main system was the pneumatics. That's the most important part, driven by two pumps, individual. Those pumps were driven by the Arduino, which we programmed on the pneumatic suction cups. You can see two servos. Those are used to mimic the 2 degrees of freedom that an actual human wrist provides. We created a open loop controller with joysticks to control those two servos, just as a user input control. Eventually, if Pranav's lab uses this idea, they would integrate it with their sensors, and it wouldn't be user input because the whole point of the robot is, to be self-powered. The 3D printed parts, we did a lot of 3D printed parts. The arm you can see is a replica of Pranav's robot's arm, and then we designed around it, basically.
So a lot of the design philosophy when completing this project was trying to come up with a product that could ultimately be used in Pranav's lab while still staying modular and not totally committing to one design. So we could tweak it as we go and come up with the best final results. This proved to have some challenges with wiring, but ultimately we were able to position everything in a spot where the wiring would be as short as possible while still maintaining efficiency. And this can also be seen with the Arduino. So we soldered on leads to joysticks and buttons just to leave ourselves more room for testing and to give Pranav's lab more options for their testing as well with how they might want to implement it.
Many of the parts that, as discussed earlier, many of the parts were 3D printed. However, it should be noted that some of the parts were laser cut instead. This distinction was based on the fact that laser cut parts were stronger and the print time was much less as they were cut using acrylics in Makerspace. The process was a bit different than 3D printing as the file type needed to be converted to a DXF file using AutoCAD, and the specific orientation was chosen to be cut. Once all this was done, the files were then submitted to Makerspace to be cut.
And to determine that, to ensure that our product works, we perform various testing for different types of grippers, mainly by increasing the weight linearly in order to determine the maximum amount of force each gripper can provide, and to ensure that nothing fails in terms of understanding what types of objects we can pick up. We also performed testing on different types of surfaces, different types of like gripping. This was all again to make sure, our hand can pick up a variety of different objects of different sizes, weights, and from different movement types, either vertically, horizontally, etc.
And that's our project.